everyone, myself Sai Prasad, a lecturer in the Ahmedabad High School and the Junior College. Welcome to the series of the lectures of 10th class maths. We have started the discussion of sets. We have started with the definition. We have seen belongs to subset, superset, universal set, union, intersection, everything. Let us solve few problems on them. Okay. The first set, they gave x as that x is a natural number. Okay. The next, B such that x is an even natural number, odd natural number and a prime number. Okay. He is asking us to find A union B, A intersection B, B intersection B intersection D. Shall we do? See here, this is given in set builder form. We have to write in roster form. What are natural numbers? That is 1, 2, 3, 4 and so on. He didn't give any limit. That's why I am writing it as so on. The next, x is an even natural number. What are the different even natural numbers? 2, next 4, 6, 8 and so on up to the last final number. How much you can write? The next, x is an odd natural numbers. That is 1, 3, 5, 7 and so on. Is it clear? And the next is x as that x is a prime number. What are the prime numbers? 2, 3, 5, 7, right, 11 and so on. These are the different prime numbers. Is it right? Now he is asking us to find these sets, that is A union B. Hope you remember what is A. A is 1, 2, 3, 4 and so on. B is 2, 4, 6, 8 and so on. Then A union B. Union of these both, right? 1, 2, 3, 4, 2, 4, 6, 8. However, whether it is an odd number or whether it is an even number, it is a part of this natural number. Therefore, that is nothing but 1, 2, 3, 4, 5, 6 and so on up to infinity. Is it right? The next, A intersection C. A intersection C. Right? A is a set of natural numbers, 1, 2, 3, 4 and so on. C is odd numbers, only 1, 3, 5, 7. Right? The intersection will be always 1, 3, the next 5, the next 7. It is nothing but set of only odd numbers, that is 1, 3, 5, 7, 9 and so on up to infinity. Right? The next is B intersection C. B is 2, 4, 6, 8 and so on. Odd is 1, 3, 5, 7 and so on. Is there any common thing in those both? There is no common in between even and odd number. Can you find here 1, no 1, 2, no 2, no 3, no 4, no 5 and nothing. Right? There is no common between B and C, which is nothing but 5, which is a null set. Okay. The next is B intersection D. That is B is 2, 4, 6, 8 and so on. G is 2, 3, 5, 7, 11 and so on. Is there any common between even and prime numbers? There is only one element, that is 2. Okay. Did you understand? Is it clear? What are the different things we have to remember? We have to convert a set builder form into roster form. Then we have to solve the different values. Okay. If he asks us to find the intersection of any these both, that is A union B intersection of A intersection C. This is just for our practice. A union B, A intersection B. Is there anything common in both of them? 1, 3, 5. The next? No 6, no 7. Right? What are these actually? These are natural numbers and these are completely odd numbers. That is only the A intersection B, C will be the common, that is 1, 3, 5, 7, 9 and so on. Is it right? This is how we will solve different problems. Okay. Is it clear? Now let us move on to the next problem. Now see here, the question given here it is A is 3, 6, 9, 12, 15, 18, 21. B is 4, 8, 12, 16, 20. C is 2, 4, 6, 8, 10, 12, 16. D is 5, 10, 15, 20. He is asking us to find A minus B, A minus D, B minus D and D minus B. Shall we do that? Let's do. What is A minus B? Let us write set A as 3, 6, 9, 12, 15, 18 and 21 minus what is B? B is 4, 8, 12, 16 and 20. Right? What is that we have to do here? we have to cancel the common numbers. What are the common numbers here? 12 is common. Still any number is common between both of them? No, there is no number. Therefore we can write it as 3, 6, 9, 15, 18, 21. That is equal to 3, 6, 9, 15, 18, 21. Is it okay? Similarly, what is A minus D? That is, what is A? 3, 6, 9, 12, 15, 18 and 21 minus what is D? D is 5, 10, 15 and 20. Isn't it? Now let us check the common terms. What are common? 15 is common, right? Only 15. There is no 5, there is no 10, there is no 20. Okay. Then let us write the remaining elements. What are they? 3, 6, 9, 12, 18 and 21. Is it okay? The next thing is B minus D. What is B? B is 4, 8, 12, 16 and 20 minus what is D? 5, 10, 15, 20. Let us cancel them. Is there any element common from this term and this term? Yes, 20 is common in both the things. That is equal to 4, 8, 12 and 16. Is it okay? Let us find D minus B. What is D? 5, 10, 15 and 20 minus B is 4, 8, 12, 16 and 20. What are common elements here? 20, 20 get cancelled. I will get here it as 5, 10, 15, 20. Right? Is it clear? How did we do that? Similarly, if you observe one more thing, this is B minus D and this is D minus B. Are there any similar element between these two terms? Do we have? No, we doesn't have. That's why I always tell that A minus B and B minus A will not have any common element. Is it clear? This is B minus A. This is A minus B. Is it right? That's why remember A minus B intersection B minus A is always a null set. Is it right? Is it clear? Hope you can understand, right? Or we can simply tell it as disjoint sets. If this is A and this is B, these are called as disjoint sets. What do you mean by the term disjoint? Disjoint is they are not at all joined, right? Then what is the common term between these two terms? That is always 0. There are no common terms, right? The intersection of two disjoint sets is always a null set. Hope you can remember this, right? And not only this, there is one more thing you have to remember is equal sets. When two sets are said to be equal? When? Tell me. An equal set can be, two sets can be called as an equal sets only when all the elements of the first set is equal to each and every element of the second set. Is it okay? For example, there are two students, let us assume it to be 10th class student. School provided books to them, right? The first student is given a set of books. The second student is also given the same set of books. Isn't it? Then we can call that particular sets are as equal sets. Isn't it? Can you understand here? Is it right? Here A and B are disjoint sets, and equal sets are when each and every element of the first set is always equal to the each and every element of the second set. Is it right? Are you okay till now? Okay, let us do few more problems on such equal sets and finite sets. Okay, let's do that. As we discussed earlier about what are two different equal sets and everything, you can see here there are 6 sets given. Among this we have to define what is an equal set and everything. Okay, see here, hope you remember what is an equal set. An equal set, when two sets are said to be equal sets only when all the elements of the sets are equal. Okay, let's see that. See here, A and B are two different sets. What is A? 1, 2, 3. What is B? The first three natural numbers. What are the natural numbers? 1, 2, 3 and so on up to infinity. The first three natural numbers are same 1, 2, 3. We can write it as equal to. Is it clear? Then what about the C and D? What is C? A, B, C, D. What is D? D, C, A, B. Whether we write it as 1, 2, 3, 4 or 4, 3, 2, 1. Both are the same numbers of set. Is it clear? The same elements it has. Here A, B, C, D. Here also same A, B, C, D. All 4 elements are there. Therefore, C is also equal to D. Similarly, let us see F and A. What is A? 1, 2, 3. What is F? Set of vowels in English alphabet. Is it clear? What are those vowels? A, E, I, O, U. Are 1, 2, 3 are A, E, I, O, U? No, not at all. Therefore, F is not at all equal to A. Right? What about F and B? F is vowels in English alphabet. What is B? The first three natural numbers. Are those both equal? Again the same thing. They are not equal. Is it clear? These are few examples of equal and not equal sets. Okay. Now let us discuss about what is a finite set and infinite set. I already told a finite set is a countable number of sets. For example, the number of students in a school, or some number of pens we have, or the number of subjects we have. That is a finite set. What about the infinite set? Infinite sets we can define it as it is also kind of finite set, but we can't count till that particular point. For example, if I tell set of natural numbers up to or else less than 10, can I write? Can I define it? Up to 10 is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. If I tell only set of natural numbers, what will you do? You know what are the different natural numbers, but will you write everything from here to there? We cannot write it. See here once again, this is 1, 2, 3 and so on up to 9. Right? What about this? Set of natural numbers is 1, 2, 3 and so on. We don't know till where it will go. Right? This is an infinite set and this is a finite set. Is it clear? Hope you can understand this. This is what the whole chapter we are going to discuss. Is it clear? These are the few examples and you can solve more and more problems in your 4th exercise. Okay. And one more thing is cardinal number. What is a number? How many number of elements are that? That is defined by a cardinal number, that is n. Okay. For example, I have 3 elements in a set. Then I can define the cardinal number as 3. Okay. Let's do such kind of problem. Okay. See here, there is some set A that is equal to 1, 2, 3. There is some set B that is 2, 4, 6 kind of, right? Then how many number of elements are there in A? That is defined as n of A, that is cardinal number, or else we can define it as number of elements in a set, that is defined as cardinal number, that is number of elements in A. How many are there? There are 3, right? In B, how many are there? There are 3, right? What about A union B? Let us find. How many things are there? 1, 2, 3, 2, 4, 6. What is 1, 2, 3, 4, 6? Is it clear? That is n of A union B is equal to 5. Since there is 2 common in both the sets, I have written it only once. One more is A intersection B. What are the elements common? Only 2. That is A of A intersection B. That is 1. Okay. If you observe, A is 3, B is 3, union is 5 and intersection is 1. If I add these both, that is n of A and n of B. If I add these both are equal. Okay. Now define it as the relation is given by n of A plus n of B is equal to n of A union B plus n of A intersection B. Popularly it is called as n of A union B is equal to n of A plus n of B minus n of A intersection B. This is one of the most popular formula to be remembered in this chapter. Is it clear? What all we discussed in this chapter, starting from the definition of sets, the different kinds of sets, its representation in what all we discussed in this chapter. We have started the basic definition of sets, then the different forms, that is set builder form, roster form. Then we have gone to the union, intersection and such kind of problems, then Venn diagrams, and we have solved a few things such as equality of two sets, right, subset, the next such kind of things, finite sets, infinite sets, and we have discussed about cardinal number of two sets, right. You should be in a situation that even if they ask one of these elements and if they ask the one more thing, you have to be ready. And one more thing, see here, intersection, will there be any number for intersection if two sets are disjoint? See here, if these are the two sets which are not joined and there is no common element in this, these are disjoint sets. Is there any common element? Therefore A intersection B is 5, number of elements in A intersection B is 0. Remember that particular term. Okay, for a disjoint sets n of A intersection B is 0. Then we can directly write, for disjoint sets n of A union B is nothing but n of A plus n of B. This is for disjoint sets. Okay, till here we have discussed. Is it clear? Let us meet in the next session with a new chapter. Okay, this is for today. Thank you.